Hey guys, today we're going to be reviewing a little bit of stuff that you've done in Algebra 2. In fact, this whole unit is kind of an Algebra 2 review, and we're going to talk about logs or logarithms. And logarithms are just another way that we can write exponents, and so our question today is, how do I convert logarithms to exponential expressions? Okay, so let's first kind of review all of the pieces of logs. So this is going to be one of our log expressions, and so when I look at this guy, down here, the little b, that's called my base, just like in an exponent. So this would be log base b of a equals to x. So then what this makes the a is what we're going to call the argument. The thing that is inside the log is the argument, and then x is actually your exponent. So the thing on the other side of the equal sign is actually your exponent. So in order for me to convert this into a log expression, you kind of just make a loop. So you're going to take base, the base is the same thing, so you're going to take b to the x power and then set that equal to a. So you make that kind of counterclockwise loop, and so this expression, log base b of a equals x, is equivalent to base b to the x power equals a. So, and we can go back and forth from this. So if you had an exponential expression you wanted to rewrite as a log, you could do that using this way. So again, the base stays the same. So the big number underneath the exponent, or the log base, is going to be the same number. Your answer is your exponent in the log expression, and then your argument is the answer in your exponential expression. Okay, there's a couple of things we need to talk about involving logs, and that is, if there's no base at all, we're going to have an implied base 10. Okay, kind of like our counting system. We have a base 10 counting system. So if you saw something that said something like log base nothing of 100, they're really saying that this here is log base 10. And so what you can do with this is, we can always put on an equals to x and then rewrite the expression in order to try to solve it for x. So I would say that there's that invisible 10 down here. So I'd take 10 to the x power is equal to 100. And then that's my exponential form, and I know how to do exponential form. I'm thinking 10 to the what power gives me 100? Well, that would just be 2. Okay, so if you don't have any base at all, then it's a log base 10. There's also another type of log that you're going to see, and that is if you have a log base e. So instead of writing log, we would write a ln, which is known as a natural log. Okay, and so that's log base e. And e is actually a special number. It's called Euler's constant, and it looks like it's spelled like Euler, but it's Euler's constant. And it's just a number. It's kind of like pi. And so this number is actually on your calculator if you hit second divide, but it's equivalent to something like 2.718 blah, 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 blah. So it's an irrational number that just goes on forever, but it's called Euler's number. So e is a number. So if I had something like log or natural log of e, we know that that's going to be equivalent to 1. And that's because if I took, I don't know, log base e equals what, we would have the e to the what power gives me e, if we did my exponential form, and I would know that that's 1. So this is always going to be equivalent to 1. Okay, so just like if you had log base e squared equals, we could just think about this here, e to the what power gives me e squared, well, that would be 2. Okay, so those are some of the general things about logs. Let's practice evaluating some. Okay, and we can still just use that little loopy thing here to help us solve these problems. So if I look at this thing, number 1 says log base x of 16 equals 2. We need to figure out what that base is. And so I'm going to rewrite this in exponential form. So I would take x as my base to the 2 power equals 16. So I'm trying to think about what number squared gives me 16. Well, that's just 4. Okay, and again, we could have taken the square root of both sides, blah, 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 blah. Okay, now when I look here at this guy, I have log base 3 of x equals to negative 2. Again, rewrite this in exponential form, and we would have 3 to the negative 2 power equals x. And then this is something that I can either use my exponent rules to simplify, or remember what a negative exponent does in the first place. Remember, negative exponents flip you down to the bottom, and 3 squared is just 9. Okay, one thing to note about logs is that you can't have a negative argument, but you can have a negative answer, because you can take negative exponents. It just flip-flops your fraction. Okay, the last type of evaluating you might see is something that just looks like this, log base 3 of 27. And you can always go ahead and put like an equals a letter here. So you can rewrite into exponential form when you're simplifying out. Okay, you don't have to, but it's just something that helps, because what I'm saying here, I want to know 3 to what power gives me 27. Okay, and that's either you think about your cubes, or, well, I mean, you think about your cubes because I know the answer is 3, but you think about 3 times 3 times 3, however many times would get you 27, well, that would give you 3. So this whole expression simplifies down to just 3. Okay, it gets a little bit more tricky when it's not like a perfect number like that. So if I tried to take this, and again, I can set this equal to x, and I had 9 to the what power gave me the argument of 27. Okay, I don't know that off the top of my head. I know 9 times 3 is 27, but I don't know what power that is. And so what I can do is rewrite this expression in terms of having the same base, so having the same bottom number here. Because I know 9 is a power of 3 and 27 is a power of 3. So if I write 9 is a power of 3 and then just put that x in there, and then I know that 27 is 3 cubed, now that I have the bases that are the same, I must know that the exponents are the same as well. So I'm going to go ahead and use my exponent rules right here and know that 3 squared to the x would be 3 to the 2x, 3 to the 3, which now I can just set my exponents equal to each other and solve. So I'd have 2x equals to 3, divide both sides by 2, and I would know that that would be x to the 3/2 power. Okay, and some of you might have been able to figure that out, like knowing that if I cubed 9 and then took the square root of it, it would get me the right answer, but that's not something I know, so I always look for the common base before I try to solve these equations. Okay, that's all I got for you today. Okay, so that's a general of what a log is. Again, when you know how to rewrite it as an exponent, it makes your life a lot easier, and I will see you tomorrow.